Assalamualaikum warahmatullahi wabarakatuh. Good morning. First of all, let me introduce myself. My name is Ade Bunga Izati. I'm a student at University of Sriwijaya, majoring English Education. Now, I would like to say thanks to Mr. Petrus as our lecturers of Philosophy of Science for the opportunity for us to present today. Okay, here are our topic presentation today. The problems of induction and other problems inductivism. The first section is about the problems of induction that will be presented by me. And the second is solution and dissolution of the problem induction that will be presented by Nabila. And the third is inductivism and the history of science that will be presented by Camelia. And the last is the theory of observation that will be presented by Sylvia. First is the problems of induction. Before we discuss about the problems of induction, we need to distinguish two questions in order to evaluate inductivism as a theory of scientific methodology. The first question is, does inductivism seem to be the method that has actually been followed by particular individuals in the history of science? Second question is, would the inductive method produce knowledge if we did use it? So, the first question obviously calls for some empirical inquiry. So, to answer it, we need to gather information from artifacts, journals, letters, testimony, and so on. And then the second question is characteristically philosophical and concern not our actual belief, but whether the inductive method will confer justification on beliefs that are produced using it. Then, after this, we will return the first question later, while the next section we will consider whether or not induction is justified. Anyone know who is he? Yup, he is David Hume. He discussed the classic discussion of the problem of induction in his book entitled An Inquiry Concerning Human Understanding. Here is the biography of David Hume. Okay, in here we will define what is induction and what is the problem of induction. So, what is induction? Hume relates induction to the nature of causation of the laws of nature, and his influence on development of Western philosophy in general and philosophy of science in particular has been profound. And what is the problems of induction? The problem of induction refers to the philosophical question of how we can justify our beliefs about the general nature of the world based on the limited observed instances. So, to understand Hume's arguments about scientific knowledge, it will be helpful to have a basic grasp of his general epistemology and theory of ideas. Hume makes a distinction between two types of propositions. First is relations of ideas, and the second is the matters of fact. Relation of ideas is the propositions or statements that are true by definition, and their truth can be no true reason and understanding. They are necessary truth and do not depend on empirical observation or experience. For the example of relation of idea is, first is horse is animals, and the second is three angles have angles totaling 180 degrees. So, in this case, without do an observation, we have already known the truth of it. And then the second is the matter of fact. The matter of fact is the propositions or statements that explain the matters about the world that are contingent and can be either true or false. Contrary to the relations of idea, matters of fact establish true empirical observation and experience and just true reason and understanding. For the example is the sun will rise tomorrow. So why it claims in the matter of fact, because it's a future event that can only be confirmed by this proof of empirical observation. Hume's distinction between matters of fact and relations of idea is really correspond to Immanuel Kant, because he was inspired by Hume made the latter distinction a central part of his critical philosophy. So, he distinction between synthetic and analytic truths. In the hands of a group of philosophers of science called the logical positivists, in the early 20th century, it became a way of distinguishing form from content in formal mathematical and logical languages that were used to represent scientific theories. They thought that they could separate the empirical content of theories, the synthetic part, from the theoretical and analytic part. The positivists argued that a factual statement was not meaningful if it said nothing about any past, present, or future observation. In other words, it has no empirical content. Hume argues that just as it is only by experience that we can find out about particular causal relation, so it makes inductive inference about the future behavior of things in the world. So it is only by examining our experiences of the relation of cause and effect that we can understand its nature and see whether it is fit to offer a justification for our inductive practices. For Hume, causation is a matter of what is known as a constant conjunction. A causes B mean A is constantly conjoined in our experience with B. He identified the following vectors that usually pertain to the relation A causes B. First, events of type A precede events of type B in time. Second, events of type A are constantly conjoined in our experience with events of type B. Events of type A are spatio-temporally continuous with events of type B. 4. Events of type A lead to the expectation that events of type B will follow. So, here are call of human analysis of causation. The example of human analysis of causation is a pool ball X strikes another Y and Y moves off at speed. We say that X causes Y to move, but what does it mean? In this case, is X made Y move. X produced the movement in Y. Y had to move because X hit it. So in this case, Hume is well aware that many philosophers have held the view that X causes Y means that there is some sort of necessary connection between X happening and Y happening. But he argues that his notion is not one that we really understand. His empirism led him to argue that since we have to experience of necessary connection over and above our experience of constant conjunction, we have to believe that there is entity corresponding to the concept of a necessary connection in nature. So, Hume's empiricism means two hypotheses entail exactly the same thing with respect to what we are able to observe. Then, all other considerations that are worth worrying about are indeed equal. Although our inductive reasoning is founded on reasoning about cause and effect, this is no foundation at all since it is always possible that a causal relation will be different in the future. So, the Hume's problems with induction is that the conclusion of an inductive argument could always be false no matter how many observations we have made. Indeed, there are notable cases where huge numbers of observations have been taken to support a particular generalization and it has subsequently been found to be wrong. It is the famous case of the generalizations. All swans are white, which was believed by Europeans and the basis of many observations, until they visited Australia and found black swan. So, it makes the statement of all swans are white is false. It is argued in the Problems of Philosophy by Bertrand Russell. Okay, that's all about the problems of induction. Next, about solution and dissolution of the problem induction that will be presented by Nabila.
Okay, now I'm going to talk about solution and dissolution of the problem of induction.
David Hume is an important figure in philosophical tradition called naturalism. Hume's ideas were groundbreaking and often controversial. He questioned very foundation of knowledge. Most philosophers have not been satisfied with his skeptical naturalism. and various strategies have been adopted to solve or resolve the problem of induction.
Induction is rational by definition. People do not use the term rational to apply only to deductively valid inference. Indeed, they often describe inductive inferences as rational. One assumes that the future will be like the past and that nature is uniform. Most people would say that, in general, it is rational to base belief about the future on knowledge about the past. We suppose that reasoning is rational because it conforms to some sort of standard and that is the sort of reasoning that will tend to lead us to truth and away from falsity. We can treat Hume's argument like a paradox that leads to a conclusion that must be false, that induction is always irrational, and hence conclude that one or more of its premises must be false, although we may not be able to identify which one. Most philosophers have taken him to be a skeptic who thinks that induction is unreasonable. The second one is Hume is asking for a deductive defense of induction which is unreasonable. Some philosophers argue that Hume assumes, without any argument, that deduction is the only possible source of justification for all beliefs other than those we directly experience or remember. Hume diagnosed inductive inference as all depending on the principle that nature is uniform. But we have no reason to believe that nature is uniform in the sense that the future will resemble the past. Then, we have no reason to believe the conclusion of an inductive argument. The next is induction is justified by theory of probability. Rudolf Carnap and Hans Reichenbach, two of the greatest philosophers of science of the 20th century, they tried to construct a priori theory of inductive logic.
A priori theory is gain independent of experience. We don't need to experience things in the world using our sense in order to know something using a priori method. A priori using logic alone. For example, you know triangle has three sides without any experience in the world. You can know this fact without going out in the world and seeing triangles. Instead, you can understand this concept using logic alone.
Induction is justified by a principle of induction or of the infirmity of nature. Kant's idea about certain principles can be known to be a true priori because they are descriptive of the way our minds work. From the modern perspective, Kant's belief in a synthetic a priori knowledge seems hopelessly optimistic.
The next is Hume's argument is too general. This response is to argue that Hume's argument is supposed to apply to all forms of inductive inference. But the descriptions Hume gave of our inductive practices were over-simplistic. Hume claimed that informing expectation about the future behavior of things we have previously observed.
Induction is really inference to the best explanation which is justified. Inference to the best explanation, which is called abduction, is the mode of reasoning that we employ when we infer something on the grounds. That is the best explanation of the fact we already know.
For example, when somebody doesn't answer the door or the phone, we usually infer that they are not at home because that base explains the data we have.
The next is there are necessary connections that we can discover. Hume assumes that we cannot observe the necessary connections that are supposed to constitute causal relations. Similarly, a Humean view of laws says that there is nothing to a law of nature over and above some regularity in events. We might argue that we know about necessary connection by inference to the best explanation. Induction can be inductively justified after all, because even deduction can only be given a circular justification. Induction must be justified by either a deductive or an inductive argument. A deductive argument with the conclusion that induction is justified would only be valid if at least one of the premises assumes that induction is justified, while an inductive argument will only persuade us that induction is justified if we already accept that inductive argument supports their conclusions. The next one is retreat to probable knowledge. Although this response to the problem of induction begins by conceding that we can never be 100% certain that a generalization will continue to hold in the future, the probabilist argues that we can come very close to certainty and that's all we need for the justification of scientific knowledge. And the last is agree that induction is unjustified and over an account of knowledge. Even we can solve or dissolve Hume's problem of induction, we still need to provide some positive account of what it is or something to count as evidence in favor of hypothesis. Such an account is called a theory of confirmation. Sometimes we need only observe something a few times before we conclude that it will always behave in a similar way. This shows only that we need to describe our inductive practices in more detail before considering whether or not they are justified. But nonetheless, it's argued that Hume's argument doesn't give us any reason to doubt them just because they are inductive.
Talking about inductivism and the history of science, of course, we have to know what is inductivism means. As we know that before, inductivism is a philosophical approach to the practice of science that emphasizes the role of induction in the generating scientific knowledge. So, means that the inductivism has connected with the history of science because it has played a significant role in the history of science, particularly during the early modern period. Well, here are the providing of an overview from inductivism and its historical context in the development of science. First is inductive reasoning. Second is empirical observation. And the third is generalization. Inductive reasoning. With inductive reasoning, the argument's conclusion is highly probable if the premises are true. So, instead of being absolutely certain like deductive reasoning, with inductive reasoning, the argument is meant to establish a higher probability of the conclusion. With the evidence we have, it would seem highly unlikely that the conclusion would be false. So, what is the example? Look at for the first example here. In a premise 1, for 10 years dog has not bitten me. And the premise 2, I will be walking past the dog today. So for the conclusion is, the neighbor's dog will not be biting me today. Making observation or observing means that we use our senses to notice things. Humans have 5 senses. First is taste. Second is touch. Third is hearing. Fourth is smell, and the last is sight. For making the observation, humans use these 5 of senses to know the characteristic of the object. Just take a look this one as our example. We can observe this example through the sense like we can look at the object from the color and from the shape. This one is the rectangular and the radius. Also, we can see the size of the object. You can use our sense also from the touch, that we observe this object texture and also the weight of this object is light enough to pick up, but it feels rather heavy in our hand. So means that from the touch we know about the weight of this object. Also, we can feel this object from the touch that this one is raw. And for hearing this object, actually this object no voice or no sound, but we can hitting it with the hammer, so it will make a sound that this tells you the object is hard. All of these observations help us to recognize that this object is a brick. Here are some questions that related to your sense, that how does the object can observe. The first one is how does the object feel, and then what color is the object, also how does the object taste or smell, and the last one is what does the object sound like. Those can help us for making observation. Next is generalization. What is generalization? So, you may not know it, but you make them all the time. Let's see. We make the generalization like this. All kids go to school. Most puppies are cute, and etc. Generalization can conclude from the statements. Well, the generalization contains these clue words. Generalization also can be valid or invalid. The valid one can be seen from the fact, also from the example and the logical sense. For invalid, no fact cannot be proved and no reason. Historical context in inductivism. First, talking about the Baconian inductivism, which Francis Bacon. One of the earliest proponents of inductivism was Francis Bacon, an English philosopher and statesman in the 16th and 17th centuries. He advocated for a systematic and empirical approach to scientific inquiry. Bacon believed that knowledge should be built upon a solid foundation of empirical evidence and that the scientific method should be inductive, involving the collection of data and the development of general principles from the data. Second is early modern science. During the early modern period, inductivism played a crucial role in the development of modern science. Scientists like Galileo Galilei and Johannes Kepler used empirical observations and the data to formulate their laws of motion and planetary motion respectively. Third one is challenges to inductivism. Despite its historical importance, inductivism faced several challenges over time. The philosopher Karl Popper, for instance, argued that the scientific knowledge doesn't progress through induction, but rather through a process of hypothesis testing and falsification. According to Popper, scientific theories should be subject to rigorous testing and potentially refutation rather than merely supported by induction. And the last one is talking about the scientific method. The rise of the scientific method, as it is understood today, incorporates elements of both inductivism and deductivism, as advocated by Popper. So, the scientific methods involves making observation, forming hypotheses, conducting experiments, and refining theories through iterative processes. So, as a point that we got, in contemporary philosophy of science, inductivism is not as dominant as it once was. Instead, there is a recognition of the complex interplay between observation, theory, and experimentation in the development of scientific knowledge, while empirical observation remains a critical aspect of science. It is often combined with deductive reasoning, hypothesis testing, and the model building to create a more holistic understanding of the natural world.
My name is Sylvia Pratami. In this opportunity, I will explain the material about theory and observation. Of course, we need some experiment when we try to find a new theory. The accuracy of experimental techniques depend upon being able to detect and screen out extraneous influences. This process is called idealization. Often science proceeds by studying ideal systems where various complicating factors are not present, and then applying the derived laws to real systems and modifying them as appropriate. Bacon recommended that we free our minds of all preconceptions when undertaking scientific inquiry. But is this possible, and is it even desirable? We have seen how to be plausible as an account of the scientific method. Inductivism must admit that we need to use background knowledge to screen out causal factors in which we aren't interested. It may have seemed okay to start from scratch in background time in order to avoid being misled by the received Aristotelian wisdom that had become dogmatic and unproductive. But 19th and 20th century scientists were building upon well-established and complex theories. Modern science is so complex and developed, it is absurd to suggest that a practicing scientist has no preconception when undertaking research. Scientists need specialized knowledge to calibrate instruments and design experiments. We cannot just begin with the data. We need guidance as to what data are relevant and what to observe, as well as what non-causal factor to take into account and what can safely be ignored. There is another problem with inductive inference that we face. Even if we could show that the future is like the past, the problem was discovered by Nelson Goodman and is known as the new riddle of induction. Goodman supposed that the future will be like the past. For example, we observe that every emerald we have ever come across has been green, and so we infer that all emeralds are green. This is an exemplary case of enumerative induction, where the generalization is supposed to be supported or justified by the observation of a large number of instances consistent with it and none that contradict it. And suppose to that we have observed emeralds under a wide variety of conditions. Now consider the property GRU, where a thing is GRU just in case it is observed prior to the year 2001 and is green, or it is only observed after 2001 and is blue. Now, all emeralds we have observed up to now have been GRU by this definition, and hence all the data we have supports the generalization. All emeralds are GRU, just as much as it supports the generalization all emeralds are green. The predicate GRU is artificial, but Goodman's point is that we need some way of distinguishing those predicates with which we can legitimately make inductive inferences. We can call this projectable predicate. From those predicates which we cannot legitimately make inductive inferences with, we can call this non-projectable predicates. Goodman's problem remains even if we solve the ordinary problem of induction, and it also shows us that we need to say more about observation. On the simple model of observation, we have assumed it is just a matter of setting up some experiment and recording what happens objectively. But the possibility of GRU-type predicates means that we will get into trouble if we record our observations in the wrong language. From all of the material that have been explained before, we can conclude that, first, sometimes new theories refine our understanding of the data we already have before. In general, the former cannot be simply read off or inferred from the latter. For example, we come to regard the deviations of the path of the planets from perfect ellipses not as observational errors, but as revealing the effect of the planets' gravitational attraction between themselves. The second, the history of science has often involved the introduction of new concepts and properties that could not have been simply inferred from the data. The third, theories guide us in deciding what to observe, under what condition, and especially in the case of modern science. Presuppositionless observation would be detrimental even if it were possible. The relationship between theory and observation is much more complex than it seems at first sight. Fourth, many different influences, dreams, metaphysical beliefs, religious beliefs, and so on, may inspire a scientist to propose a particular hypothesis other than the data he or she already knows about.